Welcome, everyone. Welcome, Kate, Paul, and Rahul. Thanks for joining us. There's more video for the new video for the Azure Task channel. And if you don't follow the channel, just click the subscribe button, hit the notification button as well, and follow us. And we have the pleasure today to have someone from the Microsoft engineer team, from the Open Service Mesh team, that's also work on the open source projects, on CNCF projects for Gateway API for Kubernetes. That's the future of like Ingress. And welcome, Kit, Mattix, and we're pleasure to have you here. He's going to be the main speaker. And Rahul is our MVP. Have a few videos here on the channel. Welcome back, Rahul. Rahul is a product manager for Logic Monitor. He works from Sydney. And Paul is in LA. He's from my team, Cloud Developer Advocate team. Welcome, Paul. Yeah, great. Kate, present yourself and yeah, go ahead and tell you what you have prepared for us. There's a discussion more than a presentation, but yeah, go ahead and let us know what you have to impress and show from this CNCF project. And many people here follow CNCF. We have videos from multiple projects, and people are always interested to see, is OSM, is like Gateway API, a project where we can help? We have a few developers that are looking for projects to collaborate. Maybe you can talk about this as well. Welcome.
Absolutely, and I just want to say thank you for the invitation to talk with y'all today. Like you mentioned, I'm Keith. I'm a senior engineer lead on the Open Service Mesh team here at Microsoft, and I'm excited to talk to y'all about Gateway API. Gateway API is a Kubernetes subproject under SIG network of Kubernetes. And as you aptly described, it is the future of the Ingress APIs within Kubernetes. And before we get too deep into Gateway API itself, I want to first back up and talk about Kubernetes and the Ingress process. Kubernetes as a container scheduler or container orchestrator, it tries very hard not to be too opinionated about what kind of proxies that you use, especially for getting traffic into your cluster or sending traffic throughout your cluster. And this was a purposeful decision when Kubernetes was originally released. You've got the Ingress resource as well as the Ingress class resource that allows you to essentially plug and play whatever kind of Ingress implementation you might like. Common ones out there look like Nginx Ingress. You've got Contour coming from VMware Project Contour. You've got different service meshes may have their own Ingress. For instance, Istio's Ingress Gateway. You can plug and play any of those into the Kubernetes Ingress resource and describe routes and rewriting and describe traffic coming into your cluster and execute any number of traffic policies or control on routes and things of that nature. And that's what exists in Kubernetes and what existed 3 or 4 years ago. Gateway API is essentially in a very it's an attempt, and it's doing very well to rewrite some of those APIs, start from scratch, and think about the core of what users need to accomplish with traffic routing for Ingress. First Ingress and now service meshes we'll get to in a second within Kubernetes. And there are a few core resources that are built into Gateway API that are the core of routing logic, with more updates happening all the time. It's a vibrant community, lots of different contributions from people from organizations all across the globe. And we would love for people to find more about the project, which is why I'm excited to talk to you all about it. So Jorge, if you don't mind, I'm going to start sharing my screen and start walking through some stuff. But I'll pause first to see if there's any high-level questions. Sounds great.
If someone want to ask something first, like many people ask, what's an Ingress controller? Why I need like a Gateway API or Ingress controller? I think it's a good start for someone like new on the Kubernetes space.
Yeah, for sure. So as to why you need an Ingress controller, To do some definitions, ingress just means to enter into, is what that word means. And so when we talk in the Kubernetes context, what we're talking about is the way that traffic gets from outside your cluster to inside your cluster. That's the ingress process. And so an ingress controller is a Kubernetes controller. A controller in Kubernetes is just something that watches your cluster. And so an ingress controller is something that looks at your Kubernetes cluster, sees the different ingress resources that you've programmed, that you've provisioned within your cluster. It sees those YAML manifests, and it does things. It takes action based on those manifests. That can look like standing up a load balancer. It can look like adding configuration to that load balancer for certain routes or services that exist in your backend or within your cluster. Your ingress controller can do any number of things. You have TLS configuration, et cetera. And so for users who want to be able to, that you've done the work of setting up a Kubernetes cluster, and now you want to expose it to the world. You could use load balancer services, but let's say your cluster has to be private. And you've got to have this demarcation of public to private traffic that happens. Well, Ingress controller is the way you go about doing that. And so Gateway API is a new way to configure those ingress controllers in a way that's hoping to be relatively standard across the industry, so that you can port one set of configuration, one set of policies from one set of proxies to another. Does that help kind of get some background on the use of ingress controllers?
Yeah, it helps a lot. And I think one thing we all agree here is that the ingress was kind of too simplified version of a definition, and now the gateway API is filling the gaps, it's kind of extension or kind of revisit for that. It's kind of, they say, okay, ingress was too simple, wasn't covering all the use case. And now we're going to see, the gateway API, how is that now thinking for the future? Maybe Ingress was created I don't know how many years ago, but we couldn't see all the use cases at the time. And we hit the ceiling there, the limitations, and now it's great. Yeah, share your screen. Let's see, go more in details on the gateway. And what do you think, Paul?
If I could just make one comment. I mean, you said it was probably a little more simplistic when they originally designed it. And then as you can see, as you started working more and more with Ingress and you needed different features, that's when you start to you have to start messing around with some of the annotations, right? Because that was the way that they implemented a lot of the customizations is going through that route. And so you always have to fiddle with documentation, figure out who's doing what annotation. And so I'm excited to see this.
Absolutely. And that was one of the first party concerns of the Gateway API. So I'm actually going to, on that note, share my screen here. And what I'm going to show is the original blog post for the Gateway API on the Kubernetes website. And this is an old blog from April of 2021. And can you all see this, by the way? Just want to make sure all the text stuff is working. Awesome.
You might want to just bump up the
zoom in a bit. Yeah. Let's zoom that in a bit. Make sure everybody can see. So, like I said, this is the original blog post from April 22nd, 2021, and I believe this is I think the alpha announcements for Gateway API. And going back to Paul's point about configuring Ingress and some of the complexities around that, what we saw in the industry is a lot of different Ingress controllers re-implementing the same kinds of controller. So you had contours, CRDs, or custom resource definitions looked a lot like Nginx's, or looked a lot like Istios, and they were doing the same things, but the APIs looked very different. And so in KubeCon 2019 in San Diego, a group of contributors basically got together and said, we could probably do better. We can abstract this a bit and deduplicate a lot of this work. Another point that was brought up was around the annotations that you often see being used with Ingress. If you want to, for instance, set a client cert on a incoming request in order to authenticate with MTLS, for example. Doing that's going to look different between different Ingress controllers. And if you're using the same Ingress resource, that's going to have a different annotation with a different key, often a different value each and every time. And so for users of Kubernetes and users of Ingress who are maybe migrating from one Ingress controller to another, or we're trying to read documentation for one Ingress controller and be able to translate to their specific use case, there's a barrier to entry there. And the annotation proliferation, really the annotation explosion, is one of the main pain points that the original creators of Gateway API were seeking to fix and to remediate. And so this, in KubeCon 2019, contributors want to do better about this. And the name Gateway API is the newer name. There have been different names in the past, but the underlying goals of what they're trying to do here was kind of fourfold. One, the Gateway API was built to be expressive, and it wanted to account for a lot of the common use cases that Kubernetes users were dealing with today, or last year technically, but in modern times. Kubernetes has had a ton of adoption and investment since it was originally launched, I believe 8 years ago. And so with all of that new investment in eyes and adoption, we're going to see people use these APIs in ways that originally wasn't expected. And so in order to accommodate some of that and to move from some of the pain points of Ingress, the Gateway API was designed to be expressive and to be able to do things like traffic weighting, TCP, header manipulation, all baked into the API. Gateway API also wanted to take into account the realities of role-based access control that are at play in large organizations. The days where somebody could, when somebody's got access to do all the things and configure all the things, that's not the realities of most production grade Kubernetes deployments. And so Gateway API understands at its core that there are going to be different personas, different people who have different roles in an organization, and it wants to make sure that each person in that role is able to do their job. It's also built to be extensible. We understand with seeing Ingress and seeing what happened with the annotation explosion, the contributors and the designers of the Gateway API are very aware of the need of the reality that you're not going to be able to solve every single use case with one spec. And so there are various different escape hatches, if you will, within the specification for advanced users to program in their own specific business logic in order for some more advanced or off-the-cuff use cases that just couldn't be codified within a specification. And finally, it's meant to have flexible conformance. With any specification, you've got to try to have some idea around are you conformant. You have to have some measure by which you determine whether or not a particular implementation conforms to the specification. And so there are different conformance levels within Gateway API, core, extended, and custom. And those different conformance levels all have kind of a sliding scale of supportability. Not necessarily just supportability, but just ways of looking at implementing the core concepts so that a feature that is very nuanced or very advanced doesn't restrict other implementations that may do things a little bit differently. So that's kind of the underlying goals of Gateway API, and that's a lot of talk. But what I want to talk about now is, okay, what does this thing actually look like? What are the resources that we're talking about here? Goals and high-level concerns are all well and good, but what are we actually dealing with? Well, I mentioned that the Gateway API understands role-based access control, and as a way of discussing that, we want to talk about the personas. We were very persona-based in the way we look at things. And so in this diagram, you kind of see the way that the Gateway API is organized. Let me know if y'all can see that or if I need to zoom in a little bit more. But at the top level, what you've got is this Gateway class resource. And Gateway class is very analogous to Ingress class, if you're familiar with the Ingress APIs. And Gateway class basically encompasses, okay, how describing common behavior, common configuration for any set of gateways. And the infrastructure provider, somebody who is, for example, if you're on a cloud provider, they are going to be the ones often configuring a set of gateway classes for a cloud load balancer of some sort. Maybe you have one gateway class for a L7 load balancer, another gateway class for L4 load balancer. That's kind of distinction that you see happen with gateway class. A gateway class is then referred to by one or more gateways, and the cluster operator, the person on your DevOps team or your SRE team, whatever team is running the day-to-day operations of your Kubernetes cluster, those are going to be the folks who are responsible for creating your gateway resources. And gateway tends to be one-to-one with an instantiation of some sort of proxy. A gateway, and when it comes to the design of the specification, is anything that translates from something out of cluster to into cluster. And so this is often a load balancer. And so that, again, that's a specific instance of a namespace instance of your L4 or L7 load balancer. From there, we start getting into the application developer use case, right? The idea of what this gateway does, what level does it operate at, what certificates does it have, that's all the responsibility of your cluster operator. As an application developer, my goal is to try to make sure that my application that I deploy, my pod, my deployment, my stateful set, can be accessed via this gateway. And so what I'm going to be dealing with as application developer are my service manifest within Kubernetes, my generic service manifest, and then the HTTP route. And there are other routes for different protocols like TCP, UDP. There is a new a proposal for gRPC, which is very exciting. But what you're going to be doing with the HTTP route is you're going to be defining, hey, on what paths are available. Should I do any header rewrites? Things of that nature. And if I scroll down here on the blog post, this is it's a bit outdated, but this is what that API looks like. You see a host name with some rules and matching with forwarding and things of that nature. So I'm going to take a pause there. That was a lot of information. And I want to turn it over to any questions y'all might have about Gateway API and kind of its goals and how it goes about doing things.
Rahul, what do you think? Rahul,
yes,
I want to see your opinion coming from STU and also using OSM, other service meshes and using Ingress. How you see that?
Yeah, so I love when standards come into play. I realize that Gateway API is actually a set of interfaces, but the implementation is actually left out to different providers. I remember when I had to work with testing out different ingresses, I had to read documentation of each one of them, and each of those had their own bespoke integration. So there was a very steep learning curve. I realized that there is a learning curve involved here as well, but this is a one-time activity. You learn it once, and then the same standard is implemented across all the implementations. So you don't have to worry about revisiting the talks of each and every Gateway API implementations. I'm also very happy that to see that Gateway API has actually taken the best bits out of the service mesh. Particularly STO is one of the biggest ones, and now it's implemented by default. It's baked into Kubernetes. So this is going to be quite interesting to see. But I would like to ask Keith how Gateway API is going to fit with the service mesh going forward.
Yeah, that's a fantastic question. And to clarify, the Gateway API, the way that we go about doing work and contributing to Kubernetes is actually a little bit different than a lot of resources that, projects you've seen in the past. Gateway API is actually being developed outside of Kubernetes. And there's a couple of reasons for that. One is so that we can continue to iterate quickly without being beholden to Kubernetes release schedule and a lot of the overhead that comes from contributing to Kubernetes. And so the idea is that once we reach a certain maturity level with Gateway API, to be able to merge that back into upstream Kubernetes. And so it's a little bit of a different contribution model than what some folks might be familiar with. but we're really excited for the velocity we're able to accomplish. And why do I bring that up? Well, because you asked about service mesh. And historically, service mesh and Kubernetes haven't really mixed, right? Service mesh has been an abstraction on top of the Kubernetes platform for years, as long as it's been around. But what really started down the path towards switch to a different page here that kind of talks about some of our initiatives around mesh. But what got us down this path is we realized that a lot of the resources around routing, mainly, so HTTP route, TCP route, TLS route, gRPC route now, all those resources that are being used for the Ingress use case, there's no reason that those couldn't be used for the east-west use case as well. And east-west, meaning service to service or within your cluster, as opposed to north-south with Ingress, where you're getting in and out of your cluster. You said, wait, a request is a request is a request. A connection is basically the same. Why can't we have this single set of resources that is useful for both? And that's never been done before. And so what we did is we got together and we just kind of had a brain dump of what exists in Gateway API and what kind of problems do meshes need to be able to solve. And we looked at it and we said, hey, this could make sense. And so we started a kind of a sub project of the Gateway API, all within SIG Network. And it's called the Gamma Initiative. It's a very Avengers sounding name, but it stands for Gateway API for Mesh Management and Administration. Gotta love the backronyms. But the Gamma Initiative is kind of works in parallel with Gateway API. And as that set of people are very focused on the Ingress north-south use cases and moving the spec forward, Gamma is focused on how can we make sure that service mesh use cases and concerns are handled by the Gateway API. And we're spending a lot of our times working on those fundamentals of how do you represent a mesh within Gateway API? How do you bind a particular route to a service or and back to a mesh versus a gateway? And we are developing gateway enhancement proposals for all the work that we're doing. And interestingly enough, we actually have gotten our first gateway enhancement proposal merged into the Upstream Gateway API about a month after we started having our meetings. And so we're very happy with the kind of progress we've been able to make so quickly. And to briefly just talk about this, this is the proposal, GEP 1324. And it outlines kind of our high-level goals of what we want to accomplish with Gateway API. We're doing this iteratively, and we realize that if you try to do everything all at once the first time, we're going to miss something, and you're probably going to build something that's honestly wrong for most people. And so we've spent a lot of time trying to make sure that our scope is very tight for this first pass. We want to solve the underlying, some of the foundational problems of representing mesh, binding services and routes together. And we've covered a lot of that here in this proposal. We also have put together a glossary because different people who are using different meshes will use the same word for different concepts, right? What's the saying that's so famous? The two biggest problems in computer science are cache invalidation, naming, and off by one errors. And so we thought it would be very important for us to get together and agree on a core set of terms for having these conversations. And you see us describing service mesh, policy, routes, distinguishing within service. The word service is very overloaded, and we've had a lot of interesting, productive conversations over the roles a service plays. And so if any of this is sounding interesting, I really encourage anybody to come and jump in. This is all public stuff that you can be a part of. We've got community meetings that happen every week. And for the Gamma meeting specifically, we actually are alternating our time slots so that we can try to accommodate people from all time zones as many times as possible. So this week, actually, we had our EMEA friendly meeting at 8 a.m. Pacific time. And then that means next week we're going to have a a meeting at 3 p.m. Pacific time to accommodate those in Asia Pacific. So if this sounds interesting, we're in the SIG Network Gateway API Slack. Check us out. There's a lot of interesting work being done.
That's great. I know you guys, but even these links, you can even learn things that, the glossary there is like you can learn things there. And if you scroll up there, maybe the top proposal there, at the goals there.
Yeah.
I think we can discuss a little bit there. Rahul, I can see the sidecar agnostic is very interesting, the data planes.
Yeah, I can run through those real quick, or if you already had questions, I can go ahead and answer them, whichever y'all prefer.
Let's try to go the first one will be models and resource and modifications that you need on the service mesh implementation. How you see that?
Yeah. So I can go through them kind of and summarize them one by one. So basically, at a high level, this goal is describing the whole purpose of Gamma, and we want to change the Gateway API, add the proper models, resources, and make changes to existing resources so that the routing family of resources are usable for service mesh implementations. Interestingly enough, our work with Gamma is oftentimes adding semantics and defining semantics for what does this mean in this context for service mesh. And so this goal kind of captures that work of trying to make sure that they're usable for service mesh. The next goal is to make sure that Gateway API Ingress implementations can coexist and interoperate with mesh implementations. One of our primary goals that we want to accomplish with our work with the Gamma initiative is to make sure that somebody can have an Ingress setup. They're on their cloud native journey and they've got their Ingress set up with Gateway API. They've got the routes defined for their services, et cetera. And as they're maturing, as they're moving into day 2 operations of their Kubernetes journey, and they're ready for a service mesh, and they are reading documentation and trying to get up to speed with everything, we want them to be able to use the same resources that they're already familiar with to be able to program their service mesh traffic for east-west. And with something as complex as service mesh, in addition to all of the complexities of being in the cloud in general, we want to make that journey as smooth as possible. And so that's at the forefront of our mind as we're designing, is a turnkey experience for people coming from the Ingress background. The third goal is to make sure you remain agnostic as to the topology of how the data planes are set up. And we're aware within Gamma that there are several mesh implementations that don't have sidecars. Cilium project in particular has been doing some really cool work with eBPF and service mesh. And so we want Gateway API to work for that as well. The best specifications don't make assumptions as to the implementation detail, and we consider data plane topology as an implementation detail. The next goal is to make sure that the implementations are able to have vendor-specific extensions for their own policies that are in line with how the Gateway API already has that set up. So Gateway API has this escape hatch, for lack of a better term, called policy attachment. And it's an interface, and written in Go, it's literally like a set of interfaces that allows you to define certain behavior that occurs on a route or on a listener. And your Ingress controller or your service mesh can read that policy and apply it, and those are able to be vendor specific. We understand that specification's not going to be able to have anything. A specification that does everything is really able to do anything well. So we want to make sure vendors are able to handle their use cases on a case-by-case basis. As part of the Gamma initiative, we want to collaborate with the Gateway API community on any shared patterns or policies that are applicable for both use cases. And a big example of that is authorization policy. I'm a open service mesh engineer. I spend a lot of my time thinking about, authorization and MTLS and service communication. But those same authorization policies are probably useful on the Ingress side as well. there's no reason why the Ingress users shouldn't have access to those policies. And then finally, we want to just make sure that we maintain the namespace boundary that exists in upstream Kubernetes as far as a delineation point for RBAC and security, and not try to reinvent our own scheme. Kubernetes has done a lot of that work already, and so what folks are familiar with, and so we should make sure we maintain that namespace boundary. So those are all top level goals. Are there any, what do y'all think? What do you think about this?
I think that's amazing. Paul, what do you think which one was the most important from the goals there for you?
I mean, my biggest takeaway is that it sounds like we're trying to fit service mesh into the specification so that regardless an Ingress service mesh, it's all entry points into your Kubernetes resources, and they're all going to use the same exact Kubernetes API resource types. And so I think that's going to be pretty exciting, and kind of almost like I have like a sigh of relief when I see all this stuff.
and we still, Paul, leaving space for the for the vendors to kind of extend that if they need,
right,
if they need that.
But there's also a specification for that too, right? So yeah, that's awesome.
What I like is the user-based, routing there, because in Ingress today is a big problem. Like anyone can go there and create like an Ingress, and anyone with access to the cluster can make a mess. Imagine someone getting control from your pipeline, and they could deploy another version of your application, reroute to like a fake deployment, and do something very bad if they get access to a pipeline. And companies are sharing classes still. They share classes, just separating by namespace, and these I think bring better level of management, because what happened is, because of this problem, people start blocking Ingress and just leaving for like operation to change the Ingress. But means that you have to synchronize if like different pipelines doing that, and means like an outage for the application, because the Ingress is actually the most important point where you switch versions. If you want to do like a rolling deployment without having control of these Ingress, it's pretty hard. Have you guys had this problem in production? Like I saw that many times, and we never had like a proper control. I saw some things for Kubernetes that controls like at the resource level, and people create like a role-based access control for everything on Kubernetes. But some other things that they have to maintain just because they want to maintain Ingress. And now, is that clear, Keith, that we have a solution for that? Yeah, now.
Yeah. If I'm understanding your case correctly, the issue is that, from our back perspective, you have to shut down the Ingress resource, because the people who hold the power to Ingress can do whatever, and so that becomes a very privileged resource. But with Gateway API, and that's going to be the case in Service Mesh as well, for Ingress and Service Mesh, what we're going to allow people to do is, in Gateway API, you can use it for Ingress. There are I'll go to this page here. There are many implementations on, where is it? There's a whole list of different implementations of Gateway API, about 19 different implementations, 17 and 19. And so this is something that folks can play with right now. But to your scenario, somebody can, when you deploy your application, you deploy the routes for your application within your namespace. That's something you can have control over. And the gateway, the controller has the ability to accept or deny certain routes. You can enforce certain policies. So let's say you want to enforce a timeout or enforce HSTS header on all the routes that are happening that are bound to this gateway. You can do that with Gateway API. So your application developers are empowered to be able to deploy things on their own, and it's all based on with RBAC policies. Only you can limit the access to the gateway configuration there to just those who need that access, and it's a safer security posture for all those involved, especially those, like you mentioned, George, in multi-tenant deployment scenarios. So that's a big improvement within Gateway API over what we had previously.
Yeah. And Rahul, you want to ask that big question that we talked many times is how API management fits on this builder. Like how API management, I can see Ambassador there, I can see Kong there, and I still think that we don't have a clear vision, for the customers or for the community around how API gateway fits on this thing. I see like Kong and Ambassador doing an Ingress controller that can do the whole thing, but normally they don't do as a sidecar because it'd be too costly to have, this huge Ingress or sidecar that can do anything. What do you think about that? What do you think? Rahul can comment first and make sense of the question? Or?
Yeah, sure. Yeah, but I just wanted to start with a remark that the Gamma proposal that Keith presented, I really like the goal that they've actually taken into consideration that several service mesh implementations already come with an Ingress resource of their own. And in order to adopt the Gateway API, the customers don't have to rip out their service mesh onboard Gateway API and figure out how the rest of the things would work. But they can already use the Ingress resources that they have, but also get the best thing about the Gateway API, which is the segregation of responsibilities between different personas out of the box. So that the problems that you just stated, George, that unauthorized people don't make changes to Ingress resources and crashing the whole cluster, those kind of problems won't occur at all because of the responsibility segregation that we have. So that's a really cool improvement, Keith. Good work to you and your team.
I'm honestly, I just got involved with Gateway API recently. There are folks who've been doing this for years, since 2019, and there's some incredibly smart people who've made a lot of contributions to this API, and the community is going to, I think, really benefit from a lot of the features and the design that we're seeing here today.
Yes, yeah, that's a really nice thing to see as an and I also realized that we've taken the learnings from the storage classes implementation that we have a similar segregation of responsibilities with who provisions the storage resources and who uses them. And we have implemented a uniform model throughout Kubernetes now, just like the storage classes, we have these gateway classes. So I think the users would find it very easy to understand and see how Kubernetes is doing things. As a Microsoft MVP, I would obviously like to see some Microsoft resources in this list. So just like George, I'm keen to see API management service.
No pressure, Kit, no pressure.
I'll work on it.
we can help. If it's open source mesh, we can help. AKS. Yeah, Paul, we can work with Kit as well. And yeah, we pretty sure that we are aware of that. And
hopefully
like
we'll have some
Gateway API
representation
still
soon.
early versions, but yeah, there are products already using that. Like you can use that now in production if you want, but still alpha. Most of them you can see alpha. Keep in mind that even if they have, it's still in alpha. Like.
Yeah, and keep in mind that the API itself just recently hit beta about a month ago, and so now is a really great time to start looking and getting involved because the API has gotten a level of maturity where people you can see folks no problem putting iterating on it, and it's reached the beta milestone, which is really big within Kubernetes. And so now is a really great time to I know I'm going to be talking to my stakeholders within Microsoft, the teams that I work with in AKS, and try to see if we can get some implementations here. And I think it's a great time for anybody else to do the same because now's the time.
What would be the next milestone after beta? Is it generally available after that point, or what's the next step?
Good question. So there is a whole versioning section on the website. Between, it's further down. Yeah, so from alpha to beta, and I'll zoom in here for you. But yeah, so resources move from alpha to beta, and then beta to GA. And that's the next milestone, and that milestone has some adoption pieces of it. We require a minimum of 6 months to soak as a beta API. We have to have multiple implementations using that API that are conformant, and a majority of the fields, most of the supermajority of the fields, honestly, have to have, and the behavior have to have conformance test coverage and wide implementation and usage. We're not interested in advancing a specification forward, and I see this both as a Gateway API contributor and as a lead of the Gamma initiative. We're not interested in pushing forward a specification that only a select few people use. We want the community as a whole to benefit from this, and so that's one of the blockers, or the gates rather, for that beta to GA milestone. And the Gateway API upstream is well on the way to hitting some of those goals as far as adoption. And we're iterating to add some of the, listening to users and getting feedback and making sure we're adding those use cases into the API. And, as that 6-month time expires, I'd be really great to start seeing some of these resources hit GA in the Gateway API. It'd be really exciting.
Sounds great. I have one technical question there that I see some Ingress controllers, they, like even Nginx, there is one version, or used to have a version, or Azure Application Gateway Ingress controller, they forgot about the service and they manage the pods directly. They talk with the pods, they bypassing, the service. I don't know if you've seen that. I'm not sure how that's going to be on Gateway API, if there will be an option where, like, if you set like a route, that's just going to be updating like an Ingress controller that could be even running as a fully managed service in a cloud provider. And another thing is, routing definition for service mesh is completely different from normal Ingress, because it's more like defining who can talk to who, like service A can talk to service B. It's not just opening like a single route to one specific service. It's more like a definition of who can talk to who, and that could becoming multiple routings, opening multiple connections. And yeah, I'm not sure, is one thing what you're going to define, and another thing is what the controller is going to be creating as routings. And yeah, maybe it would be the route will be quite different from the existing one that we have on the Gateway API, in my opinion.
Yeah, so I'll take your first question first and then go to your second question. Yeah. So as far as Nginx bypassing service, I'm not super familiar with detail, but what I can say about Gateway API is that when you do your routes, they're going to be setting backends to services in the cluster, and so the service resource to be is the way you specify your backend for traffic splitting, for example, or just the typical 100% everything going to a service. The service resource is the way to go about that. Or if you happen to have implementation that has a separate resource, you can perhaps use that wrapper resource instead. But the service resource is kind of the foundational piece for routing. Your second question, and this is something that's close to my heart as service mesh engineer. Yeah, that's the word I'm looking for. Mesh engineer. The routing is very different. And there is a problem within service mesh, or it's a problem with solutions, but there's a problem called the contextualization problem. And it's essentially, for any given instance of a service, I work with sidecars. So in my case, for any sidecar, what services can talk to this sidecar? What routes does this sidecar know about? And what routes know about my sidecar. And to be quite honest, in Gamma, we are working on that as we speak. We are, at the time of recording this video, we're working through 2 or 3 different proposals for adding this information or adding the patterns for this kind of work within the Gateway API. And our goal is to try to make sure it looks as similar as possible to the Ingress case. And so there are a couple ways to go about this. One is to have the routes exist and then make your service mesh controller have logic around what's able to talk to or what's able to talk to other to whatever else based on separate policies that you define. So you can kind of have it open by default and then have policies to block, or you can set a policy to deny all by default, RBAC policy deny all by default, and then only kind of allow list certain routes to other services. That's honestly still up in the air about how we go about expressing that in the API. So I guess my answer to that is stay tuned. And if you've got a strong use case, let us know. Again, the cool thing about, I'm very passionate about open source, because the cool thing about this conversation, this work that we're doing is, if you're watching this and you say, I've got a use case I want to make sure is covered, you can hop on Slack, you can file a GitHub issue, you can kind of attend our community calls. Everything's happening in the open, so your voice can be heard if you want us to keep in mind.
You guys have any use case you want to tell him, Paul?
No use case, but I was just clicking around on the Gateway API page, and I just landed onto the contributing and community section. A lot of information in there on how to get started, so this is pretty cool.
And by the way, follow Paul. Paul is new on my team, and he's doing a lot of new content there. And Rahul is an MVP here from Australia as well, and he has books and webinars, and is going to be talking at NDC Sydney about Open Service Mesh. That's in October, Rahul, correct?
Yes, that's correct.
If you are in Australia, follow him as well. And Kit, that's amazing. My use cases are more multi-classes on external service, like service runners on VM. Mm-hmm. And there's always like a firewall in between there. And we want to avoid going back to the old days where we have to open a request for the firewall team to open the firewall. It takes 5 days. And if you don't fix this problem, then for the enterprise, it'll be a nightmare. It'll be hours like a shoe. I think we all agree on that.
Yeah. I hear you. And quite honestly, the multi-cluster use case is a bit out of scope for what we're trying to do right now, just because we're trying to get a lot of those foundational things to solving the base case and then expanding to fit the multi-cluster case. But I mean, to your point, how do you communicate across these clusters is the age question. It's probably been around as long as Kubernetes itself has. And there have been multiple approaches to this between kubefed. There is the multi-cluster service API that come out of Sync multi-cluster. That's kind of the foundation of a lot of conversations around this. And when we get to there in Gateway API and in Gamma, absolutely one of the use cases we're going to consider is, okay, how do we allow users to specify things like packet encapsulation for or DNAT rewrite, changing the IP address to the east-west gateway use case, in other words, that people who are familiar with meshes might be familiar with. Egress is another use case that's popped up a lot. Monitoring the egress traffic and say, hey, no, you're within a demarcated zone, so you can't talk to anything outside this cluster, because you've got some kind of compliance requirements around this deployment. It's got to be air gapped. And so egress control can allow enterprises to do that with these same resources. So the sky is literally the limit. I've been around APIs and Kubernetes for a little bit, and I'm really impressed with what the folks behind Gateway API have done with these APIs. And they're, like I said, they're expressive. There's for vendor-specific extensions. And so I have no doubt that we're going to be able to create something that works for a good number of use cases, and is going to make adopting Kubernetes a lot easier for the new person, with kind of the mid-size, small, medium-sized business use case, and then the giant enterprise. When you standardize, you really unlock a lot more possibilities for people across the entire spectrum of experience. And so I'm really excited with for the work that's been going on here and what's going to be in our future.
That's great. That's great. Thanks a lot, Kate. Any final consideration, Paul and Rahul? Paul, I know you're doing WebAssembly. I think we're going to have the discussion. Maybe it'll be another video how WebAssembly is going to play a role there on those, on those data planes there, or even on the Ingress, where that's going to run. But yeah, keeping following eyes on this thing. But I'm happy, and only if you guys have any considerations, fine.
Yeah, no, this was awesome. So I learned a lot. Thanks for your time, Keith. This is excellent.
No problem. I enjoyed it. I love talking about technology with folks, so I really appreciate y'all talking with me about it and listening to me ramble about something I'm passionate about.
Yeah, it was quite informative, and I love how Kubernetes is actually trying to make the lives of operators and developers easier by listening to feedback and adopting the best practices from other products, in this case, Service Mesh, and bringing it to Kubernetes. So yeah, I'm quite happy and excited to see how it evolves.
That's great. Thank you, Kate, again. And hope you see you guys on another video. And I want to bring Kate back to talk about Open Service Mesh, and that's what he's working for Microsoft. And KubeCon is coming in October. Maybe by then we're going to have more videos on Open Service Mesh as well, and keep following on the Gateway API. Yeah, thanks a lot, Kate.
So you mentioned KubeCon. I'm going to be speaking at KubeCon about Gateway API and what it means for Service Mesh. So if you're at KubeCon, come stop, say hi to me. Love to chat, or tune in virtually if that's your cup of tea.
That's great.
Nice,
That's great.
nice.
I'm probably not going to be there because travel this year is still hard for me coming from Australia, but I wish that everyone from the community that will be there, keep in touch and ask you about Open Service Mesh as well and Gateway API. Thank you, everyone.
Awesome. Thank you.
No problem.